try that again. There we go. And now I'm not just a voice coming from the void. All right, I'm gonna share my slides and we're gonna fly through this super quick. Alex's presentation is a good primer for ours. So I'm thrilled to be presenting today with Heidi Trudell, also from Guardian Glass. Paul Groleau was originally going to give this talk, but was caught up in an emergency. And we wanted to bring together perspectives from the research community, the advocacy community, and industry to talk about, the gaps in between these markers and why that's really important and some of the complexity that that entails for our work. This is a photo of a building I encountered in Ottawa last year. This was me at the time because it's a new building and they treated the wrong surface of glass and the markers were farther apart than they were supposed to be. And why I say they were supposed to be closer together is because in Canada we use the CSA A460 standard, which I'm going to note here is based on the metric system for the benefit of my American colleagues. And in the standard, it prescribes that the markers are not supposed to be more than 5 centimeters apart. And interestingly, it also explains in the standard why. Well, the studies have shown that 5 centimeters is generally more effective than 10 centimeters. Well, I'm interested in that. We're going to explore what that means today because there's different ways of talking about effectiveness. So I'm going to start with research and then I'm going to hand it over to Heidi in a moment to talk about industry perspective. Where did 2x2 marker spacing come from in Canada? I had a great conversation with Michael Mazier at FAP about this. And it starts with this building, Concilium Place, where they had a big collisions issue. And it started with the building treating the glass with light gray dots, 2x4 approximately. But the owner didn't like it. They perceived vertical lines and they found that aesthetically unappealing. Maybe some commentary on the prison industrial complex is in order here. But they then replaced the gray dots in 2x4 with white dots in 2x2. And this made them happier. It was less obtrusive to their view. It increased the density of the markers. And at the time, FLAP thought, that's great. We think that might do a better job of protecting some of the smaller birds that were crashing into that building, hummingbirds, kinglets, etc., that are not usually incorporated into product testing. And now we know a fair bit about marker spacing from these kinds of empirical tests, which Alex talked about briefly. There are the tunnels that are built in Austria and the United States. They're both noticeably different from one another. There's Daniel Klem's field test, and then there's Heidi doing a field survey of a building, checking for birds, of course. And this has taught us a fair bit about how well particular materials would pop into these test setups perform. But I want to highlight that confirming whether a product works or not does not necessarily tell us how it works. And I don't know that we've devoted ourselves fully to testing hypotheses about the mechanisms of collision deterrence. There has been research that have looked at these kinds of mechanisms, just not necessarily with glass. So here's, for example, a figure adapted from this paper, which basically was having birds fly through an aperture and looking at what they were doing with their bodies, depending on the size of the aperture. This example is notable because it dealt with small birds, hummingbirds placed inside of this little arena where they had apertures of different widths, and they were modeling how birds are maneuvering to get in between the aperture to get to food. So here's an example of what that looked like, a video from that study. And you can see the birds are really good at squeezing in between a narrow aperture. They can tuck their wings together. And this reinforces the logic behind why we think marker spacing that's tight is better for smaller birds. But we don't actually have total proof of that yet. I'm going to hand it over to Heidi next to speak a little bit on the industry side.
Thank you so much. So in the wild, there are patterns wider than 2 by 2 inches that are doing great. So these are some of the examples of what's commercially available because not all clients actually want 2 by 2. These products are available for retrofits and or new builds. Next, please. And it's really critical to know that because codes specify different things, the production side is really challenged on what they are able to both manufacture and offer as both standards or custom orders, because there's so many differences between North America and Europe, Canada and the US, and within municipalities, spacing and sizes can be very different. So in order to justify these patterns and runs, there needs to be enough uniformity within the industry to make it worthwhile. Next, please. Now, it's also really critical to point out that money. Money is a huge factor. So when you have a pattern that can be rotated 90 degrees, you might be able to get significantly higher yield. I had a call like 2 or 3 weeks ago from a greenhouse in Ohio that was going to lose about 40% of their glass because the pattern was going in the wrong direction. So that is a substantial loss. So the more glass you can get, the better. Next, please. So the directional pattern in this example shows you exactly how bad that can be. That's both like carbon footprint levels of waste and cost. It's just really expensive. Plus, fabricators and window installers are then up against the aesthetic of their client who wants to line up every single stripe exactly, and it can be absolutely maddening. So, as Brendon pointed out, that vertical stripe thing at 4 inches, maybe we do need to have a chat as a society. But yeah, when you have patterns that can't be rotated, it's significantly more complicated for folks who are stocking the glass as well as manufacturing it. Next, please. Okay, so yes, regularly spaced patterns that you can rotate for maximum yield is significantly more economical than your directional patterns. Next. So it's also really, really, really critical to note that the industry is only testing glass. Like, if it is not a glass product, in the glass, on the glass, two-dimensional, it is not getting covered. So there are obviously Acopian bird savers, louvers, fins, I don't want to say awnings, but like the shade structures that go in front of glass, metal grills, different perforated either screens or other decorative metal panels. Those don't have a consistent testing methodology. So when you do have three-dimensional objects in front of the glass, this changes both how birds interact with it, but also how it looks from approach. And so these measurements should not be like one-to-one translated, because they do not work. Thank you, Leora. Next, please. So yeah, Peter and Dan have figured out that 2x4 works great in Pennsylvania. It is what they recommend across the board, but I do want to point out that their test in winter in Pennsylvania does not include hummingbirds. Next. So University of Chicago has 3x3. Seems to be working fine for them. Next, please. So there is also this misconception that Alex pointed out that more is better, and not necessarily. By the time you have that homogeneous coverage from a distance, it all just blurs together. There's nothing that creates contrast or adequate spacing for a pattern to jump out as something that a bird should fly around. Next, please. Okay. So Martin Rossler does have some pretty good discussion about how size and contrast should be shifted in accordance with lower contrast, bolder pattern. But it is every building is a snowflake, every pattern is a snowflake. As Alex pointed out, every lighting condition and scene is going to be different. So taking that into consideration is really critical. Next, please. I think we're back to you.
Yeah, and just want to end on the previous slide with that it might these one-size-fits-all approaches to the minimum marker size need to take into account other variables like the shape of the pattern, the material that's used to dictate whether that is going to be detectable to a bird or not. So I'm going to wrap the presentation here with a third part, which is focusing on an advocacy point of view. And I want to share excitedly that we've had actual progressive policy for this passed in Canada. Actually, wait, this slide is out of order. So I'm going to speak to this briefly. there are some research gaps that I think as a community we should be paying attention to. Building on what Alex was talking about previously, I'm interested in these smaller birds, and we speculate when we say that really, really dense patterns are needed to protect the smaller birds. We should be able to show that with experimental results. Does having larger markers allow you to have wider spacing? Quite possibly. And how does this translate across these different categories of materials that Alex showed? I think beyond just testing, does material A or material B work, we need to fund basic research to understand the mechanisms of how all these technologies work. And that will allow us to move away from relying so heavily on animal tests towards better calibrated models, which we can then use to scale up evaluation processes and meet market demand. And so now getting back to the advocacy section, I think we all can relate to this. We've seen these decals applied incorrectly on windows, and birds are unfortunately still being killed anyway. What's new in Canada is that we actually have stronger protections against deceptive marketing practices. So I'm going to suggest, without naming names, that some of these promotional materials that you'll see on packaging and on websites are actually misleading the consumer a little bit when they describe inadequate spacing as good or better. When you say that you're protecting the lives of beautiful birds you love by slapping a couple of stickers up on your window, I mean, does that actually stand? Do we have data to support that? Um, you know, I don't think we should be relying on anecdotal evidence, to be honest. I think we need to demonstrate a higher level of quality control. And so in Canada, we've updated our Competition Act to clarify the rules around greenwashing, that if you claim a product has an environmental benefit, you need to demonstrate that with proof. There needs to be rigorous testing. It needs to meet a standard. And just sharing this as general guidance for our community, that it's not just about what you advertise, but the impression that you're giving to consumers. If you have just a couple of stickers in a package and you're telling them, go buy one, treat your windows, you're protecting birds, what is the general impression of that transaction? It's also really important to avoid exaggerating the environmental benefit of that product. And so if you want to learn more about this, you can check out the website for the Competition Bureau in Canada. And I'd be happy to connect offline if anyone wants to discuss further. And with that, I'm going to end on a silly picture, and thank you for your attention.
Wow, that was a minute early even. So we have lots